Hello and welcome to Algebra 2, Chapter 3.2, and today we're going to solve linear systems algebraically. So remember from 3.1 we solved them graphically, and so then our answer was the ordered pair in which they shared. So there are two ways to solve a system algebraically. We're going to discuss both. The first way is the substitution method. And so here's your steps of what you're going to do. First of all, you're going to solve one of the equations for one of the variables. It really doesn't matter which equation, really doesn't matter which variable, but I would make it as easy on you as possible. So if there's a variable that has a 1 as a coefficient, that is always going to be easier. You're then going to substitute that expression you found for that variable into the other equation. It's going to produce an equation with just one variable in it, and you'll solve for that variable. And lastly, you're going to substitute your now known variable back into one of your two original equations and solve for the other variable. So let's see how that works. So step number 1 was to solve one of the equations for one of the variables. My suggestion would be the first equation for y, because it's the only one with a 1 as a coefficient. So you can subtract 3x, divide by -1, or I'm going to add y. So we're going to get 3x equals 13 plus y, and then I'm going to subtract the 13, switch it around here, y equals 3x minus 13. So there's step number 1. Step number 2 is to substitute that expression into the other equation, and it has to be into the other one. You can't put it back in itself, it's not going to work. Okay, so y equals 3x minus 13. So I'm going to replace y here. So it's going to be 2x plus 2 times y, which is 3x minus 13, equals -10. That has left me with an equation with only one variable. It appears twice, but it's only one variable, x. And we can solve something like this. So we're going to distribute, combine like terms. Okay, add 26, divide by 8, x is 2. So there is step 2. Step 3 is to solve or to substitute that value into either original. Now, granted, you could go into this equation here, but if you've messed up getting there, you're putting it into a messed up equation. Now, if you messed up getting there, then your answer is probably wrong too. So my suggestion is an original equation. I'm going to go into equation 1. It doesn't matter which original, they're going to give you the same answer because the two equations share this point. Remember, you're finding where these lines cross, you're just doing it without graphing. Okay, and because of that, your answer must be an ordered pair. So they cross at 2, -7. Okay, so your answer is still an ordered pair. It's the ordered pair where these two lines cross. You just did it without graphing them. So let's try that again. You want to solve for one of the variables, and personally I would choose that x there. If you solve for any of the other ones, you're going to end up with fractions, and then if you want to deal with fractions you can, but I know you don't all love them. So this time I'm going to go ahead and just subtract 3y. So we'll do it -3y plus 1. And when you divide by -1 to get x by itself, make sure you divide everything by -1. So x equals 3y minus 1. So that is step 1. Step 2 is substitute that expression into the other equation. So we're going to have 4 times 3y minus 1 plus 6y equals 8. So then we're just going to solve for y, because now that's all we have is just y. So 12y minus 4 plus 6y equals 8. That's 18y minus 4 equals 8. Now here's going to be a great example why solving algebraically I think is sometimes better than solving graphically, is because we have an ordered pair that does not have integer coordinates. And you're never going to get exactly 2/3 from a graph. And that really is why we need to have it algebraic ways and not just graphical ways. Alright, so I got y I'm going to plug it into the top equation again because I like how that 3 2/3 is going to cancel there. So the 3's cancel. And negative x equals -1. If I divide by -1, x equals 1. Okay, so my answer, making sure that you always write it as an ordered pair, there's my answer. I forgot to show you on the last one, these, you really want to check them. Okay, easy to check, just plug in your numbers, so it'd be -1 plus 2, -1 plus 2 is 1, and 4, let's see here, 4 plus 4 would be 8. So take the 2 seconds to check them, you always make sure you're right. So our second method is what the book calls linear combination. I'm more familiar to it as elimination, which to me, because you're eliminating a variable. So your steps to this one is you're going to multiply one or both equations by some constant that you're going to have to come up with that's going to obtain opposites. Now I teach this that we're going to always add the two equations together, so we definitely want opposites because when you add opposites together they cancel. Then you're going to add the two equations together, and when you do that, whichever one had opposites is going to cancel, so you're going to be left with one variable, so you're going to solve for that one variable, and then you're going to end with the same step as before on substituting back into one of the originals and solving for the other variable. So we want one of our variables to have opposites. So if you look at your x's, they're already opposite signs, which is great. They would become 6's because it would be your least common multiple. So they would become 6's if you wanted to do it that way. And thus they would both have to be multiplied. Or if we look at our y's, already opposite signs, which is good, they would become 6's as well, but the top one is already a 6, so you're only having to multiply the bottom one. So you might venture that route. It's a little less work. I'm only going to multiply the bottom one. I'm going to multiply it by 3. Okay. You're going to totally rewrite the system. So here's my top equation that did not change. My new bottom equation is -9x plus 6y equals 30. And we're going to add these equations together. So adding the columns, this is going to be -7x, that cancels, equals 49. So solve this. This is step 2. Solve the remaining equation. Get -7. And then ending up how we ended up before, we're going to plug that back in. I'm going to plug it into the top equation. 2 times -7 minus 6y equals 19. -14 minus 6y equals 19. Adding 14 to both sides. -6y equals, let's see here, 33. Divide by -6, and then we'll simplify this. -11/2. Okay, so again, writing your ordered pair, -7, -11/2. There's your answer. Okay, and one last example. Again, we want to try to get a variable to eliminate, so we want opposites. Looking at the x's, 18, make them both be 18, or looking at the y's, you'd make them both be 20. Completely up to you. I'm going to go with the x's. You get the exact same answer if you went with the y's. So we're going to multiply the top equation by 2 and the bottom equation by 3. And that's because I want to make those x's become 18s, and that's what I need to multiply to get there. So distributing all the way across, 18x minus 10y equals -14. -18x plus 12y equals 6. We're then going to add them together because our opposites will cancel. 2y equals -8. Divided by 2, y equals -4. Plug that back into one of them. We'll do the bottom one. Plus 4 times -4 equals 2. -6x minus 16 equals 2. Add 16 to both sides. Oop. And that's a 6. Negative 6x equals 18. Divide by negative 6, x equals negative 3. And remember, you always put your ordered pair where they cross. All right, that's what I have for 3-2. Let me know if you have any questions, and have a great day.